I'm starting off today's video with the answers to last night's assessment. Again, you were using one inverse operation, either using the addition property of equality or subtraction property of equality in order to isolate the variable. So here are your answers. Check to see how you did. We're going to go one step further into our solving of one-step equations by looking today at the division property of equality. And that just simply states that if you divide each side of an equation by the same non-zero number, the two sides will remain equal. Let's look at a couple of examples. As I look at this first problem, I see that I have 4x divided by negative 84. I'm going to divide both sides by 4. That's going to eliminate the coefficient there, and I'm going to divide, and I get x is equal to 21. If I do the check, and again we found out that the check is important, especially if we're dealing with signs, 4 times 21, we're going to multiply and get 84. It works. The second problem, again this time my variable's on the right. I'm still going to isolate it by using this division property of equality and dividing by negative 7. I'm going to see that the signs are unlike, so I get a negative 4 is equal to x, and I'm going to do, once again, the interchange. When I do an interchange, I'm going to just reverse and have x is equal to negative 4. Let's take a look now at the multiplication property of equality. You can multiply each side of an equation by the same number, and that will help us isolate the variable. This is a division equation. X divided by 3 equals negative 9. I'm going to use that multiplication property of equality and multiply both sides by 3. That will eliminate the 3 and isolate the variable on the left. And I have a negative 9 times 3, unlike signs, gives me a negative product. And I have x is equal to negative 27. Let's see that division problem again, and in a division problem we'll do the inverse operation, which also means we're using the multiplication property of equality, and we're going to multiply both sides by negative 4. That leaves me with x is equal to a positive 32. Why? Because a negative times a negative is a positive. Let's do a sampling of all the types that we've encountered so far. Let's do some that involve addition or subtraction or multiplication or division. Let's just take a look. If I see subtraction, I'm going to add. By adding, anything plus its additive inverse will cancel out. Isolating my variable, I get x is equal to 16. Second one, I see another subtraction, so I will add. Some of them are just that simple. And I get x is equal to 74. Once again, this one has my variable on the right. I'm going to add 17 to both sides. Want to be careful with my addition. 8 plus 7 is 15. That's 9, 10, 11. I get 115 is equal to x. Interchange, x is equal to 115. Why? Because I'm solving for x. I want x to be the first thing that I say as I write the solution. Now I see a multiplication equation. I'm going to divide. This is the division property of equality. I then look at my signs and see unlike signs. That's going to give me x is equal to negative 7. Another multiplication equation, so I will divide. That's the inverse operation. I see the signs are the same. It will give me a positive answer. On to the last one on this row. I see a division. I'm going to multiply both sides by 2. That eliminates the numbers on the left, and I get 24. Now when we ended last class, I said I wanted to do a couple more with that negative that we saw. If I had x plus a negative 2 equals 8. Now you know that this means we're going to subtract. So I'm going to subtract a negative 2 on both sides. And when I subtract, I add the opposite and I get x is equal to 10. If I'm not sure that I have the right signs and the right operation, I'll do the check. I'm going to put 10 back into that equation. I'm going to add a negative 2. I'm going to see that 10 plus a negative 2 will give me 8, and it worked. We'll also see the same with a subtraction. I could have x minus a negative 4 equals 7. I'm going to add a negative 4 to both sides. Let's add negative 4. I then simplify this. This cancels out, and I get x is equal to 3. I don't know if that's right. I have to do a check. I'm going to check by taking that value of x3 into my original equation, and I want to know, does that equal 7? Well, when I subtract, I add the opposite. When I simplify, I get 7 equals 7, and it works. And that's all we have with our one-step equations. They don't really get much more complicated than that. So once again, we'll practice some more, and next time we'll move on to a new section. Have a great day.